revised about 15 years ago. So if you take a CCA exam, you may have some questions about waste management. Secondly, we hear a lot talk about soil health or soil quality these days. Typically, we deal with NPK nutrients, right? We're taking the other nutrient for granted, it's carbon. So Dr. Jason Warren actually highlighted some of the testing or importance of carbon. Well, we don't manage it carbon or apply carbon. The plants get carbon from atmosphere, but cover crops will add carbon to the soil. And then there's waste, animal biosolids, will be another source of carbon. So with that amendment, you can build up your soil health much quicker. Without carbon, I don't think you can really improve soil health. The last importance to talk about this is, we have manure everywhere, right? So whether you care or not, it's happening. So we have to pay attention and do a better job. This is from Oklahoma Ag Statistics. I know most of us here are working for crops, but they're not number one, number two commodity in the state. So right now, wheat is number 4, the other crops even down the list. So we have more cattle here than people in the state. Lots of chickens, pigs. So what happens when you have this many livestock and poultry? Besides the beef, meat, chicken, they generate a lot of waste. So depends on how we manage them. It could be a liability or can be an asset to a farmer. So to me, it's a really good asset to agriculture. But if we don't manage it correctly, it can become an issue, especially the impact on the environment, like air quality or water quality. So I'm going to spend the next maybe 20, 30 minutes highlight some of the issues we need to pay attention in order to better manage the waste from livestock and humans. So we know manure very well from the feedlots, or swine farm, or chicken houses. People generate waste too. Every municipality has a wastewater treatment plant. So they produce a lot of waste. After the treatment, if the waste meet EPA standard, it can be land applied. It's called biosolids. It's a nice name. Basically, it's a sewage sludge. Okay? So the waste treatment plant will using mostly aerobic digestion. Animal waste actually using anaerobic, because anaerobic is much cheaper than aerobic. That's why we pay a lot in our utility bill, because they use a lot of money to treat the waste. After they separate the solids from the liquid, the water is good enough to discharge to streams, rivers. But the solids, they have to find a way to recycle it. I think in the US, almost 80% of biosolids or sewage sludge is land applied, but there's still some maybe landfilled. To me, that's a waste. We should utilize this material. So biosolids is from the wastewater treatment plant. Manure is from livestock poultry operations. I'm going to just talk both of them together. Then why do we need to use this material? Well, first of all, plants require 60 nutrients, right? Where do you buy a fertilizer contain all 60 nutrients? You can't. But those organic amendment, manure, biosolids do contain all 60 nutrients. They may not be in the right ratio we want it, but it's all there. Okay? So the other factor is they supply organic matter. It's a carbon, right? And this carbon is more stable than the plant residues when you add this carbon to the soil. with carbon or organic matter will help to hold more water. I heard each 1% of organic matter in the soil will hold 20,000 gallons of water. That's like almost 1 acre inch. That can be a success or failure for some areas with that additional water. And then with the organic carbon, the soil quality, like biological properties, physical property, chemical property, should be automatically improved. With improved physical condition, you have less erosion or runoff because the soil will hold more water. Then you're losing less soil and nutrients. And if you're using ammonia fertilizer, you have a reduction in soil pH. That's why even in southwestern Oklahoma, north central Oklahoma, we have a lot of acid soils because of continuous using those nitrogen fertilizer. But manure has some liming value and buffer capacity. It can maintain the pH. If the pH is already low, it could increase a little bit. There are lots of research have been showing that liming effect of using manure. So is it worth to use this kind of amendment in terms of the amount of nutrients in those material? Well, I have been just recently working on a book chapter summarized those concentrations of different type of manure. Like a poultry litter, mostly broiler litter, has about 50 pounds of NPK per ton. So if you're using current commercial fertilizer price, it's worth about $60 a ton. So if you can get it for $20, $30 a ton, you're really getting a good deal, okay? Now, swine manure, mostly in Oklahoma, it's in the form of effluent, mostly just water. 99.5% is water. So the nutrient content is low. But if you apply large quantity, you get significant amount of nutrients too, okay? And we had a poultry litter meeting earlier this week. Some people commented, they say the manure is not as good as used to in terms of amount of nutrients. That's not true. Actually, I looked back in the last 20 years. The concentration of NPK in poultry litter stayed about the same. It didn't change. But the swine effluent, the phosphorus decreased a little bit. And I talked to a swine nutritionist, Dr. Scott Carter. He thinks it's due to improved feeding, like supplement less phosphorus fertilizer to the feed. So actually that's a good thing because sometimes we have too much phosphorus relative to nitrogen in the manure. Biosolids has a lot of water. I help Fort Sears, the military base, to apply their biosolids on land. So typically 83% is water. Okay? They can dewater it or can just apply directly. But they have significant amount of nutrients as well if they're using large quantity. So it's a valuable product to me. It has nutrients and organic matter. We should utilize it appropriately. There are lots of examples showing how manure can benefit, increase yields. But for biosolids, there are not as many as studies. Fortunately, Oklahoma State used to have a long-term study from 1994 to 2006. Here showing the results of using biosolids compared with ammonium nitrate as a source of nitrogen, and then with a check without nitrogen. As you can see, for all these years, most of the years, the yields from a biosolid treatment was as good as ammonium nitrate. So it does show the nutrients are useful to our plants. We should use as much as we can. Okay. One of the problems of using these organic amendments like manure biosolids is the ratio of nitrogen and phosphorus in the product is not close to what we need. Typically, it's a 1-to-1, right? But you know plants need more nitrogen, less phosphorus. If they're using manure to supply nitrogen, they over-apply phosphorus. So that's what happened in the poultry area. They used to using poultry litter to fertilize the Bermuda grass lawn, pasture. The phosphorus build up and then result some environmental issues. So sometimes I tell others, using commercial fertilizer is like you go to a buffet line to get what you want. Using manure is like you go to a fast food restaurant, get a meal deal. I mean, even if I only need a burger, it comes with soda and fries. I may not need it. So in this case, you get extra phosphorus. You may or may not need it. So that's one of the issues we have with using organic amendments. So when we over-apply phosphorus in the soil, more than what plants need, they accumulate in the soil, okay? So the more you apply, the higher your soil test P is. I have done some study from Dr. Ran's long-term plots and found if you apply 14 pounds of P2O5, you raise soil test P by 1. So if you apply 140, you raise soil test P by 10. So it's not a one-to-one relationship. But the relationship is clear, it's straight. The more you apply, the higher the soil test P gets. And this is an example in Georgia. They applied poultry litter. See how fast the phosphorus increased. Just 4 years, apply 8 tons poultry litter. The phosphorus, soil test phosphorus increased from 50 to 175, 170. This is pounds per acre. So that means it can be quickly build up phosphorus in the soil, okay? Now, that would be nice in most of Oklahoma farmlands, but when you get too high, you're not going to benefit from it. So after the soil phosphorus is built up, you try to bring it down. It's a very slow process, okay? This is an example showing it takes probably 20 years to reduce the soil phosphorus from 170 to maybe 40, okay? It takes a long time because the soil ties them up, the plants really not taking much. So it's not very practical to reduce soil phosphorus by using plants taking up. After it's built up, it will be there for a long time, okay? Well, when you have lots of phosphorus in the soil, we know soil can tie up phosphorus, right? But only to a certain degree. When the soil is saturated, it starts leaking, okay? And then the ability for different soil to retain phosphorus is different. Like some soil can retain more than others, just like this cup. This can hold more water than the other ones. When it's getting too saturated, they start leaking out. So we have done some study in Oklahoma. This shows the difference of 3 different soils, Darhart, Grant, and Parsons. You know, when the phosphorus increases, they're no longer able to retain them, and then it can be lost to the environment. The main difference here is the organic carbon and the clay content. So the more clay, organic matter in the soil, the higher the retention capacity is. So we cannot treat the different soils the same way. Some soil can retain a lot of phosphorus, but others cannot. So what happens if the soil is saturated or high in phosphorus? Well, this MELIC 3P is called soil test P or plant available P. And Dr. Nathan Nelson yesterday talked about dissolved reactive P. Basically, it's a water-soluble P, okay? The higher the soil test P, the more water-soluble P you have in the soil. Well, when they're soluble in water, runoff water can carry them down slope, okay? So phosphorus chemistry is very complicated. In the soil, the total phosphorus maybe is like a basketball. The plant availability of Melic 3P, maybe it's like a golf ball, okay, very small amount. And then water-soluble P is even lower. It may be just like a dime compared to golf ball or basketball. So they're small but very significant, okay? The reason is when you have high water-soluble P in the soil, you have a slope, you have lots of rain. You have runoff water, right? The runoff water will extract along the way, including sometimes particulate P, that's the P associated with soil particle or even animal waste. So going down slope, get into water systems. Some of them may leach into subsoil. If there is a subsurface flow or tile or drainage, this can get into water body system as well. So although we say phosphorus is immobile, right? But it does move a little bit. Maybe it does not, just like we are walking, okay? That's how fast the phosphorus moves. But potassium moves too. It's like you drive a pickup on highway, but nitrate, it moves much faster. It's just like the airplane fly in the sky. That's at different speed. But phosphorus is immobile, but still some of them can get lost, okay? So why do we care about phosphorus? In the freshwater system, the algal bloom, like algae, is triggered by phosphorus because some of them can fix nitrogen. Even if you do not supply nitrogen, they can fix it. But if you limit the phosphorus, they're not going to grow. Once they get phosphorus, they start grow because they are plants as well. So the water is very sensitive. It doesn't need very much. The Oklahoma-Illinois River water standard is 0.037 ppm. So when you get over that, it's eutrophic or high in phosphorus, okay? But in order to have a problem, you have to have a sensitive water body. In the Oklahoma Panhandle, you don't have a lake or river, you don't need water that much, right? But in eastern Oklahoma, you have a source, like a porch litter, and then there's a mechanism for this phosphorus to get from land to water, like you have a slope, you have lots of rain, okay? So the risk is different in different parts of the country or state. Because of this, we can manage the phosphorus accordingly. Like first of all, we manage the source. We try to prevent the soil phosphorus from build up because once it's built up, it takes a long time to reduce it. And then once it's built up, you have more water soluble phosphorus. That's why soil test is important. It will tell farmers whether they have enough in the soil or not. And they can choose the right and the methods accordingly by minimize the phosphorus lost from the field, okay? Also, the transport is important. If you can reduce runoff, like have terrace or have filter strips, you can reduce phosphorus movement also. And the water body sensitivity, some lakes are more sensitive than others. So that's why we have a nutrient-limited watershed. Some others are not nutrient-limited watershed. So they already did some something called TMDL, total maximum daily load for different type of nutrients or contaminants. So we can implement some of the proven best management practices to taking care of these issues. So such as have a setback distance I know the poultry probably have a new guidelines, like how far you have to set back in order to build a poultry house or apply chicken manure, okay? And the buffer strip is important. And sometimes we can use in soil or poultry litter amendment. In Arkansas, they put the alum in the chicken house, lower the pH, reduce ammonia volatilization. The aluminum also tie up phosphate, become less mobile after they apply it in the soil, okay? So there are really different ways of doing that. So how do we manage this type of materials? So let's start with biosolids. That's land applicable sewage sludge. It's regulated by US EPA. In Oklahoma, it's by DEQ, Department of Environmental Quality. So the municipality has to test the material first to find out the heavy metal concentration in those materials, okay? So based on that, they can decide how can they use it or not. Like they compare the test results with one of the column here. If it's not over that, it's excellent quality. You can apply without much restrictions. If it's over that, but not over another column here, you can apply to the land, but subject to cumulative loading concentrations. That means you have to test the soil every 3 years to figure out if you over the limit. If over that limit, you cannot apply at all. Then they have to take to landfill or do something else. So DEQ regulates those. And I have a couple of fact sheets about biosolids land application in Oklahoma. So if you're interested, you can let me know and find it out. How do they calculate how much to apply? Well, it's similar to our agronomic principles. First of all, do not apply over the nitrogen requirement. Okay, how do they calculate the nitrogen requirement? Well, they consider the organic nitrogen in the material and the inorganic nitrogen. Because not all the organic nitrogen is usable by the plants in the year of application, they use a factor, maybe 40% is available first year. So if they add those mineralizable organic nitrogen plus inorganic nitrogen, ammonium nitrate, that's the plant available nitrogen from that material. If they test the soil, give a year goal, we give a recommendation. That's how they decide how much to apply. On phosphorus, potassium in Oklahoma, they're using Oklahoma manure guidelines. Okay, I'm going to talk about manure regulations a little bit. So in order to apply biosolids, they have to test the biosolids and test the soils. We do not test the biosolids here in my lab, but there are private labs in Oklahoma City or Accurate Lab, they do that. So I know some of people doing consulting for the municipalities for that. I thought this is good information to have for you. Okay? Now what about animal waste? Animal waste, if it's a large operation, it's regulated by US EPA. But at the state level, it's ODAF. It's not DEQ, so it's different. The ODAF has a Agriculture Environment Management Service Division, so they're kind of oversee that. Basically, for the large animal operation, they comply with Clean Water Act. They classify the operation. If it's large, they'll call it CAFO, concentrated animal feeding operations. Then there are different rules. They have to have a nutrient management plan, comply with NRCS 590 standards. Okay. So if you have any questions, you can contact NRCS, contact us, or ODAF directly. So basically in Oklahoma, all the poultry operation, or livestock corporation have to register with ODAF. They have to develop a nutrient management plan and in compliance with the NRCS 590 standards. The amount of application can be used also limited by the amount of nitrogen, the crop requirement and the nitrogen in the manure itself, okay? On phosphorus, there's something called Oklahoma Phosphorus Assessment Tool. It's an Excel spreadsheet. It should be on our website or the NRCS website. But in order to calculate the amount, they have to test the manure, test the soil, plus some other requirements like take records, calibrate the application equipment. So we have a nutrient-limited watershed and a non-limited watershed in Oklahoma. The regulation, the criteria is a little bit different. Soil test carries big weight in terms of how much to apply or whether they can apply or not. So I'm not going to go into more details, but if the soil test is over 400, that's pretty high. That's not an agronomic rate, but it's an allowable rate according to our regulation. They only can apply plant removal amount, which is very small, maybe half or 10 parts later. But if you are happening in a nutrient-limited watershed, the guideline is very different. If the soil test is 300 or higher, you cannot apply any. So I think the Conservation District Office probably is more familiar with this than our County Extension Office. But I guess ODAF has an inspector in different part of the state. They can help if you have any questions, okay? So when we try to help producers or livestock producers to better manage their manure, we like to encourage them to have nutrient budget balance. Figure it out how many nutrients coming into the system, how much going out, like in the form of crops, manure, and meat. What's left will be on the farm, either in the soil or just in the pile of the manure. When they knew that, they can decide if they use all the manure produced on farm or have to give it away or sell them, okay? So that's the first step. And then they have to think about some other things, try to improve the balance of the nutrients according to their management plans or the operation, like what type of plants they have growing there. Improve the feeding, probably not add too much phosphorus to the feed, and they can market the excess manure. There's a poultry litter marketing website in Oklahoma people can use, and some of them, mainly poultry houses, the company will help them whether they need to add alum or some others to reduce the soluble phosphorus in the manure. So that's important. And then another is try to utilize this manure in the field needed most, okay? In the past, a lot of people try to apply manure close to the house or where the manure is generated because it's cheaper to do that. However, those fields close to the house is built up with high concentration. They should move to the area really low in nutrients. And then if it's really high, like here is over 400 soil test P, it should not apply at all. So soil test also give them some indications where to apply or not to apply, okay? And then actually when they're doing that, they should avoid to apply in certain places or certain time. Like, if there's pounding or other situations, they should avoid. Most of dry manure is broadcast, swine effluent using center pivot or big gun. In the Midwest, actually, they inject a slurry, like dairy slurry, into the soil. that would help to minimize the losses. But it's important for them to calibrate the applicator. If they don't know exactly how much they apply, you say you apply 2 tons per acre, actually they're putting out 8 tons per acre. That happens. It's not like a fertilizer, you can do a better job. So there are ways to calibrate. I'm not going to get into that either. Okay? But if you can inject the manure into subsurface or incorporate in the soil, you minimize the loss of manure or nutrients. Okay? The NRCS people in Arkansas developed this porch litter injector. They bury a band in the pasture and then cover the slot after manure is applied. And that's a lot of work, but it's very effective to reduce the phosphorus in the runoff water. If you broadcast, you get a lot of phosphorus lost. But if you inject in a band, cover it, you basically have no phosphorus lost. So this is a big improvement, but it's not that efficient to do that. The other consideration is figure out which field is more susceptible to nutrient loss or manure loss. Because some fields may be sandier or have a slope or close to water body, you need to try to avoid that. I think Dr. Andrew Shapley from Arkansas found out most of the nutrients actually coming from small areas. So if we take care of those risk areas here and there, we solve most of the problems. And then if there's ponding, should be avoided to apply. If there is a visible erosion or drainage system here, we don't need to apply close to that. Otherwise, you just accelerate the nutrient loss. And then certain time when the ground is frozen or covered by snow, that's another time try to avoid. So the other more effective way to minimize nutrient loss from the field is to have a buffer strip. Basically, it's a managed grass area. You don't apply manure to this area. This grass will intercept the runoff, slow down the water movement, so water may going down instead of go across, also intercept the particulates. So the wider this buffer strip, the more effective. However, it would take a lot of land out of production. So you have to kind of balance. I guess they recommend at least 15 feet or 30 feet wide, because there's a really good benefits by using these buffer areas. Okay? So I guess I just quickly give you some ideas on how to give advice on biosolids land application and animal waste application. Okay? First of all, we need to understand that those materials are good resources for agriculture because they contain nutrients and organic matter. We should not take them to landfill. We should use them as much as we can. So if we do not manage them well enough, we could have a negative impact on our environment or on our crops as well. Basically, we should treat it as a resource like a fertilizer. If you follow the 4R principle, the right rate, right type, right amount, right method, right time, you're doing a pretty good job. You can minimize some of the negative impacts to our environment. There are some proven BMPs can help to improve the efficiency or minimize the impact on the environment. So if you need more information, we have a website specifically for animal waste. We don't have one for biosolids, but we do have several fact sheets. So if you go to this website, you can find more information. I think NRCS, US EPA, or ODAF, they all have websites with lots of useful information. Okay? So I guess that's what I'd like to visit with you this morning. I'll be happy to address any questions. Not very many. maybe 10–20%, mostly coming from eastern Oklahoma, where the poultry operation takes places. Now, lawn and garden is different. When I do statistics, I take lawn and garden soils out because they're not typical agricultural soils. The animal waste regulation started in 1998. Okay? Before that, there were a lot of soils over 300. It's not because it was really that high. The farmers did not know how to collect a good soil sample. They only get 2 inches or 3 inches. Then we told them, you need to get to 6 inches. And then suddenly the value dropped. I don't encourage them to get any deeper than that. Just try to lower the number.